Hello everyone, and welcome to the Data Science Salon YouTube channel, featuring videos for data scientists and data science managers who want to acquire and elevate their skills at their own pace. For quite some time, the advertising industry has assumed that targeting based on online demographic data equates to better ad performance. However, with recent changes in the data privacy laws and implementation, the entire industry will have to change the way advertisers can and should be connecting to users. It behooves all of us to find sustainable solutions that free us from relying on third-party data. Making context the centerpiece of ad targeting gives an opportunity to reduce reliance on demographic databases and put more emphasis on relevant intent signals from when the user is actually consuming your content. In this presentation, Amit Bhattacharyya, head of data science at Vox Media, describes a clustering model that connects users to the content they are consuming to identify context-based audience segments. In turn, these segments are used to train a classification model that is used in real time to inform advertisers without relying on third-party cookies.
Hey, hello everybody, welcome back. I'm happy to be here and to talk to you about something super interesting that we've been working on here at Vox Media. The title of the talk is Content-Driven Advertising Using First-Party Data, and we will delve into what all these topics mean as we go through. And just a quick, agenda so that we know what we're going to be doing. First, we'll talk a little bit about first-party data and the state of advertising. After that, we'll talk about what we're looking to do at Vox Media, which is use content and contextual signals to do some modeling. We will delve into the data science of a modeling pipeline and how we actually do this. And then lastly, we will talk about our inference pipeline, which is the thing that's more real time, that tries to figure out what to do with this data as we receive it, as well as how we apply it to advertising targeting. All right, but just to get started, first, I have a fun little video that I was having a lot of fun with, and this is something we can do to get started. All right, well, hopefully that was fun, little intro to what we're going to be talking about. It always cracks me up that the half-built Death Star kind of shows up at the end, so it's endlessly amusing to me. Hopefully it is for everybody else. But why don't we talk a little bit about advertising and what the current state of advertising is. This is actually taken from a recent New York Times article, and they were doing a profile of not showing the ad itself, but showing like what is the underlying information underneath every time an ad is served online nowadays. And, this is meant to be kind of funny. I don't know if it's real or not, but basically what's happening under the hood every time an ad is shown to you online is there's all these guesses as to your personality based on your browsing behavior, based on all the things that are happening in terms of tracking and third-party cookies in the world. And so this is just meant to kind of show you like regardless of what ad you're being shown, you are being targeted based on the information that the computer and the internet thinks they know about you. So how did this happen? So targeting nowadays is basically being driven by what are called third-party cookies. There are these cookie aggregation companies, the third parties. They collect and sell information about you and your online behavior to advertisers. These companies are more or less making guesses about your personality and your demographic information. It's very important to remember that these things are guesses because it's probabilistic. In fact, you can go online and try to figure out what the world or the internet thinks about you, and sometimes it will be oddly wrong, sometimes it will be oddly accurate, sometimes it will be oddly funny. But anyways, so these guesses aren't even particularly good or correct, but they are the best guess that these companies are trying to make about you. And then the advertisers are willing to pay to get their ads preferentially in front of people that they think line up with these personality and demographic targets of theirs. And they're definitely willing to pay more for what they consider high value targets. And then this kind of paying and deciding how much you want to pay for an advertisement online happens in these really fast online auctions. Usually as your browser is loading, I think we're all used to this, like you go to a page, the page takes a while to load. Usually the ad loads a little bit before the content of your ad or your content shows up. So this is all part of the landscape that we all live in, but things are changing. And then part of the reason, well, one, things are just changing, and then that creates a challenge for a company like Vox Media, where we are basically a free site. You come, you consume our content, and it is paid for by advertising. So the first big challenge is that these third-party cookies are going away in one form or another. Browsers are starting to block these things by default. You might have to go turn on and accept cookies. Third-party cookies are something that's definitely under heavy scrutiny. There's definitely governmental regulations, both at the state level and the national level, and more changes are just coming. And then I think the other thing is, the reason these changes are coming is that people have kind of become, very concerned about privacy and the data that's being shared. And then this ultra-targeted advertising, people are just a little bit tired of it. And, I was sort of joking in that video, I go off and buy hiking boots, and then for the next 7 days, those hiking boots follow me around, whether they're in my shopping cart or not. I am still targeted because, hiking boots are a juicy purchase. And if I accidentally left a $200 hiking boot purchase in my shopping cart, it's definitely worth the company to chase me down and get me to buy those things. And if for some reason I've already bought them, it's no big deal. And if, they get me to buy something, that's definitely worth it to them. All right, but on the other hand, we still need to provide an effective means of advertising. Just because these cookies are going away, I still think that people know that advertising is part of the landscape, and in exchange for free things, people are willing to see advertising. And even for not free things, you go to the Wall Street Journal, you go to the New York Times, it's not like these places don't have advertising at all. They have a paywall, and they still have advertising to help fund part of their business. So people are definitely used to the fact that advertising exists, but it's probably on us as a media company to do better and to do the best we can with the data that we have. And if we're going to have a revenue model that includes advertising, not only do we want a good user experience, we want a optimized revenue experience. All right, so what we're going to do is we're going to use context-based signals, which is what we'll get into here shortly. So first of all, there's lots of different contexts that you can think of, but the main context that we think of when you're on a page at part of Vox Media, this is a page taken from The Verge, and you're reading this article about cosmic rays pelting the Earth. And so what does this tell you about a user's interest? And the content itself is probably the primary thing that tells us something about the user's interest. So what we would like to do is basically identify an audience cluster centered around users that have similar types of content consumption. And that's something that we definitely can do. That's data that we have. We know that people are coming to our site. We can use first-party tracking to figure out which people are consuming which content, and we can make models of which users are similar to each other, which articles are similar to each other in various different ways. So this is what we're really interested in doing, is using our data to figure out what our users are interested in, and then figuring out what we're going to do once we know that information. All right, so let's talk a little bit about contextual signals and contextual data. The nice thing about this is that this can give us a more robust signal than is possible from like third-party data, primarily because it's our own data, as well as because we don't have to guess. So when you're reading an article about cosmic rays, presumably you're interested in cosmic rays. And even if you're not interested in cosmic rays, something compelled you to click on that article, and whether it was a social link or a friend told you to click on it or something caught your interest about the title, something got you to show up and read that article. So I would say the content of the article, the topic of the article, the sentiment of the article, all of these things are super important signals for us. And then other things that we know in the moment while any person or user is reading this article is the way that they came to our site. So whether it's through a search or referral or direct or through a newsletter of our own. The other thing is we have access to what's the stuff that you've browsed in the current session, as well as other sessions that we have access to in terms of information on the individual user. And then we will know what kind of device is being used, the general geographic location, and then also like the time, like the week, the time of day, as well as the day of week that your visit happens. And we can use that to see if like that makes a difference in terms of your behavior on the site and what you might be interested in. So for a quick example, even before we get into the data science and the modeling, thought we'd just like make a quick example of like how we might imagine using this for advertising purposes. So let's say you're on Eater, which is one of our properties that reviews restaurants, and you're reading this article about sit-down Mexican restaurants in LA. Hopefully we can all go back to sitting down and eating at restaurants in LA soon. But let's say you're reading this article on a Monday night. You may or may not be looking to go out for dinner at a sit-down restaurant on a Monday night. In fact, you might be reading about Mexican restaurants and you're in a Mexican frame of mind, and maybe that's the right time to advertise, a nice sunny beach vacation to somewhere in Mexico. On the other hand, if you're reading this article on a Friday night, the same exact article, same exact person, everything else the same, except it's Friday night, you could imagine that very likely that person's going to go out, eat some Mexican food, and you're wondering like, what's the best beer to have with that? And you could imagine advertising something that's more relevant and probably more effective in the moment rather than on a Monday night. Like, who knows? Maybe you are going out on a Monday night and maybe you do need a beach vacation on a Friday night. All of these things may be true, but this is for the computer to determine, and this is for our algorithms to determine, but this is basically a key piece of data that we're able to feed into the model and use as we think about how to pair the right kind of advertising with the right kind of content. And it's these contextual signals that we're hoping to use to build our model. All right, so as we think about the model, like we have a bit of a pipeline, so we're going to go, this is the data science-y part of the talk, so we will go into the modeling pipeline and how we go about actually doing this. This is, of all the slides, this is the most technical, mostly because it goes through the entire pipeline all at once, so I'll go through it slowly, and then we will delve into each individual part in a little bit more detail. So the basic idea of what we're doing is we're creating a network graph of users and content interactions. So not only do we understand what users are like each other, but also what content is similar to each other and how users are interacting with it. We train an unsupervised neural network to get what are called embeddings. These are numerical representations associated with the users and the items. Once we have these numerical representations, we do a pass of clustering so we can figure out what users and items are closer to each other or related to each other based on these embeddings. And then once we have these clusters, we train a further supervised classifier so we can predict the user segment in not quite real time, but I would say semi-real time when they arrive on our site. And this is the last step, even though it seems like it goes pretty quickly and it seems somewhat simple. This is like the true, like, fun, good thing that we've been able to invent, such that when you show up on the website, even if we know nothing about you, at least based on the fact that you're reading a particular article and previous behavior of who else read that article, we can predict a kind of user segment or interest segment that can immediately be used for advertising targeting purposes. All right, so let's go a little bit into detail into some of these parts of our modeling pipeline. Probably many of you are familiar with a network graph, but just in case you're not, there's a quick primer on it. Network graph is basically a data representation based on relationships. So in our case, we have our users. They represent some nodes. Those are the blue ones. We have our articles that represent also nodes that are the green ones. And in our case, a page view is a link between a user and an article. So that's technically called an edge in the realm of network graph theory, all that kind of stuff. But you can see that you can create a relationship-oriented diagram as opposed to a, like a relationship, like a regular traditional database where you have rows and columns of this kind of stuff. So this is the basis for our getting started on the modeling. All right, so we actually use something called a graph stage model. It's relatively new in the literature, and what we use for, and this is the basis for our neural network training. What we do is we start with a single user, and that's the center node here, and then we look to see what items that user has viewed. And then to get like sort of a neighborhood of the user, we look at the other users that looked at those items, and then even more items that all of those users viewed. So then we don't get just a single user and the articles they interacted with, but for each user we get this, what we call a neighborhood, and we're able to base our training of a user and items not just on individual user interactions, but these like larger sort of neighborhood of interactions. All right, so then once we have that, we put it all into the neural network model and we get what are called embeddings. So you want, like, just for a brief primer on what embeddings are, if you look on the left side, you have a bunch of words. We have man, woman, boy, girl, prince, princess, king, queen, and monarch. So there's 9 different words, and in this one-hot encoding or very count vectorizer kind of way, if the presence of a single word will just generate a 1 or a 0 in a particular matrix, and there's no particular relationship between any of the particular words. They're just, if you're going to throw them into some sort of a model, like a machine learning model, there isn't any particular relationship between the words. On the other hand, if you think of an embedding model, what we've done, and this is a toy model, it's not like I actually ran it, I just literally just made up these, kind of weightings. And you can see here, instead of my 9 dimensions, if I make up dimensions, for youth and femininity and royalty, I can say that a girl would be feminine and youthful, but not royalty. And similarly, you can just go through and sort of assign numerical weights to any one of these particular words in a way that's consistent with your 3 dimensions. So what we've done is we've reduced the dimensionality, which makes our problem much easier. And on top of that, the reduced dimensionality actually has more and interesting information such that any 2 words, if you took the cosine of them or you took like some vector dot product of them, they would actually give you some reasonable intersection such that you would be able to say like one thing is close to another. So now to get a graphical representation of this, we're going to switch away from those 9 words, but here's sort of a bunch of, objects that you might find at a Home Depot or a hardware store or something like that. And this is all sort of like clustered and visualized in 2 dimensions. And you can see what's going on is we have 2-dimensional embedding of things that are very, very different from each other, and yet things tend to kind of stick together in ways that make sense, right? Like the batteries and the chargers and the power tools are in one section, all the stuff that's related to all the things in your bathroom, in your kitchen, and having to do with water are another light blue section. So this is one way to think about how these embeddings may help you visualize stuff. And then when you actually put them on a 2-dimensional axis and graph them, you can actually see the relationships kind of popping out at you. So this is what we're doing, but a much, much larger scale, which we'll talk about just shortly. All right, so what we have is we have all these articles that have titles, and so we are looking to understand the language of the articles that are on the Vox Media Network. So we use a pre-trained language model called BERT. The nice thing about a pre-trained model is we don't have to go and analyze the whole corpus of the English language or even our own corpus. these pre-trained models make it such that you pass in a sentence and it will like give back an embedding for the titles. So for our article titles, this BERT pre-trained model would give us back a 768 dimensional embedding. And while 768 may seem like a lot of dimensions, it's actually quite small compared to the hundreds of thousands or tens of thousands or hundreds of thousands of words that you might encounter in the English language, and all the different combinations and all the different sentences that you could construct out of them. And then the idea is in this 768 dimensional space, two articles that are similar to each other will appear, quote unquote, close, in this space. So what we do is we use these embeddings in two different ways. We use these word or sentence embeddings to understand the language of our content. And then what we get out of the trained neural network is what's called a user embedding. And that is, we start to understand how users are connected to each other based on their similar consumption patterns of the content itself. All right, so, and then if we continue on with our modeling steps, so once we've done our neural networks, we have our 128 dimensional user embedding. We don't know how the users are related to each other. So the very first thing we do is 128 dimensions is still a lot. It's hard to do clustering on that many dimensions, especially at scale. So first of all, we do a reduction of dimensionality to a 4-dimensional representation using a technique called UMAP. And then once we have these 4-dimensional representation of our users, we can use some clustering algorithm. In our case, we use HDBScan, which is a hierarchical clustering, algorithm. And then that generates user clusters. And so this is just to be a schematic of what's going on, of going from like a large dimensional space to a smaller dimensional space, and then finally finding the user clusters. All right, so then once we have the clusters, this is where it starts to get really interesting because it actually relates back to our content and the problem that we were trying to solve. This is a representation of something on The Verge, which is our technology and science website on Vox Media. And so this is a bunch of users on the left side, and they are clustered using the process that I just showed you before. The fine embedding shows individual users, whereas the cluster embedding kind of like groups people together into larger groups of clusters that make sense. And then once you have the clusters, you still don't know what those people are into. You don't know what the segments are. So we have to further look to see what that cluster is. And so this is where you really can't get rid of the human in the loop. So where we actually look at the titles and the terms and the topics of people in the cluster and what is the stuff that they consumed. It doesn't help to know anything about the person per se because they're just ID numbers, and we didn't like collect any information like, oh, are you whatever? Do you live in a particular state? Or we don't know if you're likely, Republican or Democrat or political affiliation, but we do know the content that you consumed. So in this case, I've zoomed in on a cluster that happens to be one of my favorites, which is about science fiction and fantasy. And so here you can see that basically here is a cluster of people that are consuming very, very similar content. And these are the names of the actual titles of the articles that were consumed the most. And they're kind of ranked by, what's most important to the cluster. And then there's the topics and terms that go into feeding, again, the cluster membership. So now we can say like, hey, that whatever blue set of users or that blue dot that's on the upper left side, that is a science fiction and fantasy cluster. And so that's what we're going to label internally as, hey, these are the people on The Verge that seem to be interested in this particular topic more than others. All right, so now that we've gotten to the end of what we call the modeling pipeline, is that we've been able to look at our content and how the users are interacting with the content and figure out how to group them into various clusters. So now what should we do with that information? So we have built what we call an inference pipeline. This is just a very generic slide about machine learning, but you can see that we're kind of using all parts of machine learning here. We've used the unsupervised part of machine learning to get our clustering, and then now we're going down the supervised learning path, and we're going to do some classification because we know what users came in and what they interacted with, and then we've also set up all these different clusters that you can belong to. So what we would like to do is be able to predict any given user that comes in and reads an article, what cluster should we classify them into? And so that's exactly what our inference pipeline does. It's what we call a slow segmentation service, meaning that it takes a little bit longer. It's not as fast as the online auctions, so we can't necessarily stick you into a cluster right away, but we are able to say, hey, we've never seen you before and you're reading this article, so let's figure out what cluster at least goes with that one article that you're reading. And then once you've been segmented into a cluster that's associated with what you're reading, all of the kind of mechanism fires and like data gets passed around, and we'll look at that really quick. So, we put together what we call our inference pipeline. This is all kind of built on cloud infrastructure and a bunch of, APIs and a bunch of computers and APIs all talking to each other. So you can see we have the BERT NLP part, which is where like the article information is stored. We have the model file, which tells us, given a particular, which clusters are associated with which types of articles, and then a lot of infrastructure just to make sure that this happens in real time, or as close to real time as possible in a scalable way. And then this is just like an example, so you can see like a user comes in, they're reading a particular article, and there's a bunch of words that are passed into as the payload, and then the inference pipeline will respond back saying like, hey, we think you're in this particular interest segment, and the score is X, and they'll either return like the highest score or the top 3 scores, depending on how we set up the problem. So now let's just talk really quickly about targeting and advertising and how this actually works in real life. So again, targeting can be based on multiple different things. What we've seen in the past is that targeting is based on this third-party data. You can imagine doing it on content only, knowing nothing about the users. But in our case, we're doing it on users and content in a way that we think utilizes our first-party data as well as is like smarter because it takes both of them into account. All right, so this is the part that's a little like the next step beyond what's the inference pipeline, which is once we know what segment you belong to, we pass it along to a targeting platform or a DMP. And in our case, we use something called Permutive. And the nice thing about that is that our advertisers can be on Permutive and say like, hey, we want to advertise preferentially to X, Y, and Z segment. And, they can in advance say what they want to target towards. And the people that are reading these articles will have been identified as being in various interest segments. And therefore, the ad targeting can happen quite seamlessly. And then the other last part that I want to talk about is like, so you can, let's say you are a particular advertiser and you do know exactly who your demographic target is or who your likely interest segment is. You have like a menu to choose from. On the other hand, what we want to be able to provide to our advertisers as an additional service is this like optimized targeting, which is you may not know who are your best customers. You may not know who's the best segment that you need to be advertising to. So what we do is we are able to collect data for some amount of time. We're able to send these cluster IDs in the ad call. And then after, let's say, a week of running your ad campaign, we can evaluate the individual performance of the clusters related to your advertising campaign. And then we, quote unquote, target the good clusters. And the good clusters are the ones where we feel like you have enough impressions and you have an above or average conversion rate. So just to kind of visualize this, we say like target the green. So this would be, for an example, auto brand. And these are the green area are topics where this brand seems to have a higher than average conversion rate as well as a good number of impressions. So it wouldn't necessarily be great if you had a really high conversion rate but not enough people to matter. And similarly, it wouldn't be great if you had a ton of people but a below average conversion rate. So this is why we kind of target this section in the upper right quadrant as your optimized targeting capability that you see on our site. So this is something that we're able to offer to our clients as part of an optimized ad targeting package above and beyond just being able to segment people from the first-party data with the contextual signal. And so with that being said, that's pretty much it for the presentation. And so I'm happy to stop there and take some questions.
This was Amit Bhattacharyya, Head of Data Science at Vox Media, who shared his insights about context-driven advertising using first-party data. Thanks for watching, and if you enjoyed this video, please subscribe to our channel, and we'll see you at the next video.